All right, we're on. Welcome, everyone. And hopefully you guys all had a nice spring break. And I just want to make sure, can I get in the chat? Can you guys give me a thumbs up or you can hear me just so that I'm not talking to an empty screen? Again, if you have any questions, you want me to pause, any of the ways that you want to do that, probably the easiest way is to just put a comment into the chat. I will be able to pick those up fairly quickly. And and we can either pause it for a little bit, put it on a shelf until later, or I can certainly come back and explain that. Excellent. Thank you, thank you, thank you. This is awesome. So today, what we're going to do is we're going to do fractions. And fractions, what I put in my email previously is if you have a calculator, and especially if you have a calculator with a fraction button, wherever that one is, could you bring that or get that out? I've also asked that if you don't have a calculator with a fraction button, that you get on your phone, you get a fraction calculator. And a fraction calculator is going to make your life so much easier. Like I said in the email, this is like if you had a word processor without an undo button. It would just be total chaos. I would barely be able to write if I didn't have an undo button or a backspace. This is what I think how important this fraction button is. It will make your life way easier. That being said, what I'm going to do is I'm going to show you how to calculate all these not using the fraction button. But what I would also, what I'm going to do is I'm going to show you the basics so that you can do them without a calculator, obviously. If you want, at the end of the question, you want to confirm that you got the exact answer, then type it into your calculator and see if you got the exact answer. So when you hand in your test today, or when you finished your notes, you know that you have it 100% correct. You can do you can check to make sure that you've got everything right. So without further ado, I'm going to get into the chapter 3 fractions. Just want to make sure that everything is good here. And yeah, we're good. Cool. So let's start talking about what is a fraction. So a fraction is a part of a whole. So lots of people, we all start with an apple, and you can cut the apple into equal pieces. And this is really important. A fraction always has to be equal parts. I think it's only fair, you know, if you gave your brother a quarter and you got a half, that wouldn't be fair. So what we're going to do is when we're talking about a fraction, we're talking about part of a whole, and each of those parts have to be equal size. And I'm going to come back to that over and over and over. A little bit of nomenclature or how we name these things. So the top part is the numerator. There's obviously the divide line here. And the bottom line is the denominator. If you weren't able to print out the chapter 3 fractions, that's no problem. You can just follow along. Make some notes on the piece of paper that you're working with. Again, at the bottom of the course in Canvas is the answer key for the notes. And so you will have all the answers right there too. And then when you go to do the test, you can use your screen and some of your notes. So again, top number is the numerator, the divide line, and then the bottom number is the denominator. From now on, instead of using numerator or denominator, those are hard words to remember. I'm going to talk about the number on the top, number on the bottom, and the dividing line. All right, the types of fractions. There's 3 different types that I can think of right now. There are proper fractions, and proper fractions is the number on the top is smaller than the number on the bottom. So 7 is smaller than 8, 1 is less than 2, 99 is less than 101. That's the way we like them. There's times when we want to convert everything into improper fractions. Improper fractions are one where the number on the top is larger than the one on the bottom. They're like top heavy. They're like driving a van around a twisty road, you know. You have 8 is greater than 7, or 3 is greater than 2, or you could have 1,000,000 over 5. Those would be top heavy or improper fractions. I'm going to let you in here. And again, the last type that we have are mixed fractions. And mixed fractions are whole numbers mixed with a fraction. So we have 2 and a half, or 5 and 7/16, 3 and 5/6. So those are the mixed fractions. What I'm going to get you guys to do is to complete this section down here and see if you understand what a proper, improper, and mixed fractions are. So I'm going to let you guys get ahead by about 30 seconds. It shouldn't take very long to do. Oops. Okay, that's about as far a lead as you're going to get. So 17 over 25, this is smaller than the bottom number, which means it's a proper fraction. Wow, that's a really thick marker. I'm going to just change that. Cool. How about 2 3/4 as a whole number, and there's a fraction. So this is going to be a mixed. That's a better writing. 32 over 6. 32 is bigger than 6. So this is top heavy. It's an improper fraction. 33 over 62. This is smaller than the bottom, so it's proper again. That's kind of what we want. They're actually pretty easy anyways. Not necessarily what we want. 15 1/4. There's our whole number, and the quarter is going to be our fraction part. So it's mixed. We got whole mixed with fractions, so mixed. 99 over 98. 99 is slightly bigger, so it's a slightly top heavy, and we're going to have an improper. 6 over 49, that's a proper. And 2, you know what? I don't even know how this goes. It's just a whole number. I was trying to think of this. You could write this as 2 over 1, which makes it an improper fraction. Or you could say 2 and 0 whatevers, which makes it a mixed fraction. So I'm not even going to answer that one. I'm just going to put whole number as a trick question maybe. Any questions about that, or I'm just going to keep moving on? If there are any questions, actually just type them into the chat. You don't have to wait for me to ask. Now, here's where those calculators are going to make such a difference, and they're not only going to make a difference this year in math, it's going to be the next year, and in grade 11, in grade 10 and grade 11 and even grade 12. These are calculators are awesome for simplifying proper fractions, and it's actually that's one of the best reasons to use them. So there's a universal rule that says that if you take a fraction, you can multiply or divide a fraction by any number as long as you do the same to the top and to the bottom. So I'm going to use my example. I've got 40 over 60. And that's fine, it's not too bad. But I can make this into smaller numbers. That's really the reason why we want to simplify fractions, make it simpler. And there's an example like you could have 235 over 65. It's kind of a big number and they're hard to get around. And you can make it a much more simple number. That's what we're trying to do when we simplify proper fractions. So with this 40 over 60, we can divide the top and the bottom by the same number. So let's divide it by 2, for instance. So 40 divided by 2 gives us 20. And 60 divided by 2 gives us 30. That's a simpler number. There's smaller numbers. We could divide again by the same number, some other number. We could do 40, it doesn't have to be divided by 2. We could divide by 4, which gives us 10 over 15. If we divide both the top and the bottom by 5, 40 divided by 5 is 8, and 60 divided by 5 is 12. So again, 8/12 is a simpler version. Or what we could do is we can really cut to the chase here. 40, if we divide the top and the bottom by 20, which is probably the biggest number we can divide both the top and bottom by without getting some kind of decimal or more fraction. 40 divided by 20 is 2, and 60 divided by 20 is 3. And that's going to be our simplified, our most simple version. That's going to be our simplest version of this fraction. And then this brings us to what's our equivalent fractions, which are fractions that are the same. Essentially, 40 over 60 is the same as 20 over 30, which is the same as 10 over 15, which is the same as 2/3. All of those are the same. The same as like half an apple is the same as 2/4 and 1/2 are the same. Same amount, it's just written in different formats. So again, the big rule is if you're going to divide the top, you have to divide the bottom by the same number. And we're going to practice this here in the next page. All right. Oh, I've got lots more about this. I don't even know what I wrote about it. So the whole idea of simplifying is to reduce your fraction to smaller, more reasonable numbers. And you do this dividing both the top and the bottom by the same number. Again, I'm being very repetitive, but hopefully it'll make sense. You may be able to divide the top and the bottom multiple times. So for example, instead of having 230 over 345, that's a pretty messy fraction. You can reduce this to 2 over 3. And we're going to sort of practice this. So one of the examples, can I simplify 45 over 100? So the question you're going to ask yourself is, what can I divide both the top and the bottom number by evenly? Well, I know I could divide it by 5. That would be probably a good one. So 45 divided by 5 gives me 9. And 100 divided by 5 gives me 20. And that would be the simplified version. Let's do another example here. 8 over 24. And I'm going to show you 2 different ways of doing this, just so you understand that it works both ways. 8 over 24. I know I could divide, both are even, so I know I can divide it by 2. That's one of the fastest ways you can do it. So if I divide 8 divided by 2 is 4. 24 divided by 2 is 12. Cool, and I'm done. It's simplified. Well, wait a second, I can simplify it some more. Because they're both even, I can divide by 2 again. So I'm going to divide by 2 again. 4 divided by 2 is 2, and 12 divided by 2 is 6. Cool, it's simplified, but I can go one step further. Both even, so I can divide by 2 again. 2 divided by 2 is 1, and 6 divided by 2 is 3. So you can do it in multiple steps and keep dividing and dividing and dividing until it gets very simple, or as simple as you can. Now I can't simplify it anymore. 1 divided by 1, that's the only thing you could do. Or 3 divided by 1 or 3, that's the only multiples for 3. So again, I'm at the farthest or the most simplified I can get, which is what I'm typically going for. The other option is if you start with 8 over 24, and I'm going to say, what can I divide both the top and bottom by? If I want to take a shortcut and don't want to do it by 2 and by 2 and by 2 again, hey, I can just go and divide it both by 8. I know that 8 divided by 8 is 1, and 24 divided by 8 is 3, because 3 times 8 is 24. And I can go directly to this step. So again, if you know that 24 can be divided by 8 because you know that multiplication in your head, this is the way to go. It's fastest. If you don't, you say, oh, well, I know 24, you can divide by 4, or you can divide this by 4. Do it, and then you're going to get to the 2/6, and then you can go that one step further. It takes a little longer, but it still works. Awesome. Here's your guys' turn. So we're going to try to simplify some of these fractions. So 16 over 20. What number can I divide both the top and the bottom by? Well, I know they're both even, so I can divide by 2. But I also know from my multiplication tables, 4 times 4 is 16, and 4 times 5 is 20. So I want to divide by 4. Let's do 4 and 4. 16 divided by 4 is 4. 20 divided by 4 is 5. And we're done. And I know I'm done because the only things to multiply to make 5 are 1 times 5. And the only things to multiply to make 4 are 1 times 4 and 2 times 2. And there's no combinations. Like I can't say, oh, let's divide this by 2, but I can't divide that by 2. Let's divide by 5. Well, I can't divide by 5. So this is as far as it goes, 4 over 5. Okay, let's do B. So 30 over 66. What can I divide both of these by? Maybe I could divide by 3. Can I divide by 6? And sometimes that helps, is you know that you can see that I can divide by 3, but what if I double that in 6? And I'm pretty sure I can divide by 6. Either way will work. Let's do 3, just because it's the easier one. 30 divided by 3 is going to be 10. And 66 divided by 3. 3 goes into 6 twice, and this twice. And we're left with 10 over 22. I know that I can divide this a little bit further because both are even. So why don't we divide by 2 again? 10 divided by 2 is going to be 5. And 22 divided by 2 is going to be 11. Now we're sort of stuck, or we're at the bottom because this is 1 times 5 is the only thing, and this is also prime 1 times 11. So this is as far as you need to go. I'm going to just erase that. There we go. All right, let's do 36 over 48. What can I divide both the top and the bottom by? I'm going to do this the 2 ways. I'm just going to put this over here. I'm pretty sure I can divide this by 6 and 6, or even 12. And I think I could get lucky with the 12. Now, if that doesn't make sense, I'm going to do it the other way because I want to do it the slower way. 36 divided by 12 is 3, because 3 times 2 is 6, and 3 times 1 is 3. And the bottom, 48 divided by 12 is 4. Now, if you don't remember your 12 times tables, that's no problem. That's totally normal. What I'm going to do is I'm going to say, I can look up here and I can say, I could divide this by 6. Let's do it by 2. Let's just figure it out slowly and slowly and slowly. So I could divide by 2, divide by 2. 36 is going to be half of 30 is 15, and another 3, 16, 17, 18. And 48 divided by 2 is 24. So these are equivalent fractions. These are the exact same fractions, just written with a different size of piece. I could divide again by 2 on that one. Both of these top and bottoms will divide by 2. So I'm left with 9 over 12. Can't divide by 2 anymore, but I bet you I can divide by 3. 9 divided by 3 is 3, and 12 divided by 3 is 4. Same answer. Slightly different way of getting there, but that's no problem. Okay, I'm going to give you 30 seconds or 20 seconds to try this one. I'm just going to be busy here for 1 second on this screen. All right. The obvious one for this question is I think that I can divide both of these by 10. So let's divide by 10. 110 divided by 10 is just 11. And 1,000 divided by 10 is going to be 100. And that's all I can do. It's simplified. All right, I'm going to pause. Any questions about simplifying? Because I think that we're going to move over to the next little chunk here. Okay. So a lot of the time, we're going to need to convert between mixed fractions and improper fractions. So a mixed fraction, remember, is like a whole number and a fraction. And we want to make this when we're going to add and subtract, what we want to do is make them improper fractions, and I'll show you that in about 1 minute or 2 minutes here. I'm just going to show you how to do this. So essentially, there's 3 steps. You multiply the bottom number times the whole number. So this number and this number, you multiply them. So it's 4 times 2. Gives you 8. We're going to take that answer and we're going to add the top number. 8 plus 1. This will make more sense because I've got a little trick down here. Is 9. Then we're going to take this number, this answer 9, and we're going to put it on top of the original bottom number. So it's going to be over 2. Now you're going to say, oh my God, that was way too confusing. This is why I've got this cool little graphic here. Often what I will do is when I'm converting is I will draw a little arrow here. And this tells me when I'm drawing my arrow, this first step, I have to go 5 times 3. This is a big times here, which is 15. And this is going to be an adding. I'm going to add 2, so 15 plus 2 is 17. And it goes on the top part of the fraction. And then I draw an arrow across the bottom, and the thirds stays the same. I haven't changed the size of the pieces. And I can explain this way more detail if you want of why this works. But I think probably what will make more sense is if I do a couple more examples, and I'll let you guys do it as well with me. So I'm going to flip over to page number 3 here. A few more examples. And apologies, I erased it because I thought it would be way more interactive if I actually got to draw these. So again, when you're doing these, I draw a little arrow. It doesn't have to be like a fancy arrow like this, but it reminds me, 3 times 4 is 12. Oops, here, I'm going to do this. I'm going to do a times and a plus. 3 times 4 is 12. Plus 2 is 14, and I'm going to put that up top here. So again, I'm just following my arrow here. 3 times 4 is 12, plus 2 is 14, and the bottom number, the denominator, stays the same. And it's done. Now, let's not simplify this or anything. That's not our intent. What we want to do is just to make it into an improper fraction. Okay, you guys can continue on with these. I'm going to just give you another maybe 10 seconds head start, and then I will continue and I'll just explain how these all work.
Yeah. All of that, just make sure we're trying to get some exercise. And then obviously
Okay, cool. So again, I would draw my little arrow around this way. So we're going to start here. 4 times 5 is 20, plus 3. So 4 times 5 is 20, plus 3 is 23, and it goes on the top. This bottom number, the denominator stays the same, and it's 4. I hope this all makes sense to you guys. I'm going to put a times and a plus. So I'm going to put my arrow in. 11 times 6 is 66. 67, 68, 69, 70. And the bottom number stays the same. Cool. You guys are way ahead of me probably, but that's all right. I'm going to catch up. 4 times the whole number 1. So 4 times 1 is 4. Plus 3 is 4, 5, 6, 7. So the top number is 7. And the bottom number stays the same. 7 fourths. Sorry. Okay, this one. 6 times 5. 6 times 5 is 30. Plus 5 is 35. That goes on the top. And the bottom stays the same. It stays the same fraction. If we're talking sixths, we're just making them into sixths. Making it hard for me to pronounce that. All right. Here we go. 4 times 2 is 8. Plus 3, 8, 9, 10, 11. So I'm going to put 11 on the top. And the 4 stays down here on the bottom. So 11 fourths is the same as 2 3/4. This one, it doesn't have the fancy drawing, so this is what I would do. So I'm going to put a little arrow here to remind me this is the way we go. 8 times 1 is 8, plus 7 is 15 over 8. I'm going to do the same thing here with the arrow. 7 times 2 is 14. 14 plus 6 is 20. And the bottom number stays the same. And lastly, I have 6 times 3 is 18. 18 plus 5 is 23, I hope. If I make a mistake, please roast me in the chat. Okay. So now we've gone from mixed fractions to improper fractions. Well, there's got to be a way of going backwards the other way. And sometimes we need to do this. And converting from improper fractions to mixed fractions is a little like a division with a remainder question. So if we have 17 over 5, it's improper because the top number is way bigger, it's top heavy than the bottom number. So what we're going to say is out of the 5, this bottom number, how many groups of 5 can we take out of 17? Okay, so I know that 3 groups of 5 would be 15, which sounds pretty close, and it's not over. It's like Bob Barker rules. I don't even know if that reference makes sense. And then if I take 4 groups of 5, that's 20. I don't have 20 to take out, so I have to stay with 3 groups. So essentially what I'm going to do is I'm going to say 3 times 5 is 15. 15 fifths here. And I still have 2 more. Out of the 17, I've taken 15 in here, so I still have 2 more fifths in this pile. And 15 over 5, you can do this in your calculator, 15 divided by 5, it's going to give you the whole number of 3 and the remainder of 2 out of 5. Okay, let's do 25 over 9. Oops, I made that even more messy than it was. That's all right. So again, the question is, if we're dealing with 9 on the bottom, how many groups of 9 can we take out of 25? Without going over, of course. So we could take 9, one group of 9 would be 9. We still have 16 left over, so we could probably take 2 groups. Let's try 2 groups is 18. Yeah, we can still do that. 3 groups would be 27, too many. So we have to stick with the 2 groups. So what we're going to do is we're going to take out 18 ninths. That's 2 groups of 9, right? 2 times 9 or 18. And what's our remainder? 25 minus 18, so 5, and then 2 more to make the 18 is 7. 7 ninths remainder. 18 divided by 9 is going to be 2. And our remainder is 7 ninths. I'm not going to draw all over that because it's already nice and clean. All right. Any questions so far, or are you guys ready to rock page number 4? Cool. So again, here we go, 11 fourths. How many groups of 4 can I take out of 11? 3 groups of 4 is 12. That's too many, so maybe 2 groups. 2 groups of 4 is 8. 3 groups would be 12, which is too much. So I can't use that. How about 2 groups of 4, which would be 8? That's just underneath. So what I'm going to do is I'm going to take 8 fourths, and I'd have 9, 10, 11 fourths left. So 3 fourths left. And 8 fourths is like 2. And I still have 3/4 left. 2 3/4. So 11 fourths is the same as 2 3/4. Now, if you guys are getting a headache because you're thinking, oh my gosh, is this what math's going to be really like? This is why I'm going to show you these guys right towards the end. Once I've showed you the hard way, then I'm going to show you the easy way. All right, so let's do 16 over 3. How many groups of 3 can I get out of 16? Well, I know that 5 times 3 is 15. That's pretty close, and that's right underneath. So let's use that. We have 15 thirds, and we would have 1 left over, because 15, if we took 15 away from 16, we'd have 1 left over, or 1/3 left over. 15 over 3 is really 5, right? And 1/3. Cool, let's do this one. How many groups of 5 can we take out of 27? Well, I'm pretty sure 5 times 5 is 25. So, and that's really close. It's just underneath the 27. We wouldn't have room for another 5. So let's use it. 25 fifths. We still have 2 fifths to deal with because we had 27 of them. 25 and 2 more is 27. So here we go, 25 divided by 5. Yeah, thanks, Taya. I'm trying to race through because I realize that it's at this point in the presentation that I always realize, oh my God, we're running out of time so quickly. And I will definitely go a little bit slower. Thank you again. And like I explained to a lot of people, is this is where having your multiplication tables just ready to go really quick makes this way easier. If you don't, it's no problem. And this is why I want to show you this button. A lot of students, they get to grade 10 or grade 11 and they know their multiplications, but it's a lot of mental work. It's like lots of energy to remember what it is, or like, what is 8 times 7 or 9 times 6? What is the difference between those? It's really hard. I totally get that. And that's why I want to give you some tools, because you know what, math shouldn't be about how well you memorized multiplication. It should be, can you figure out the logic behind solving math and use a calculator to help you if you need that. So anyways, if it seems like, oh my gosh, the multiplications are just really hard for me, no problem. This is totally normal. I'll have to tell you a story someday, but I won't do it now because I don't want to waste any more time. Here we go, 25 divided by 5, and you can do this in the calculators. You type in 25 divided by 5 just to make sure it is 5, which it is. Cool. And it's because it's 5 times 5 is 25. And we still have 2/5 left over, so let's just leave those there. Okay, and the last one is 43 sevenths. And this is a bit trickier one because 7 is a tough one for multiplication, for remembering that. I know that 7 times 5 is 35. Oh, I think I can probably get another one. 7 times 6 is 42. Okay, scrap that one. Don't worry about that. I definitely want 7 times 6 in here. 42 is just under 43, which is perfect. So I'm going to do 42 sevenths. And I still have one more seventh left over. And 42 sevenths, if you do 42 divided by 7, or 42 divided by 7 is 6. Sorry, this is just my own little notes. So we're going to have 6 and 1/7. All right. Perfect. You guys, we're doing really well here. Okay. I thought I'd put in a little section about this, and it's kind of obvious. How do we add whole numbers to fractions? So if we had 6 plus, or we have 2 plus 1/2, well, it's the same thing as saying 2 and a half, or it's the same thing as saying 2 1/2. You can just squish them together. It doesn't matter. When you say 6 and 1/7, it's assuming that it's 6 plus 1/7. We don't have to write that plus in there. We just assume that it is. I just thought I would put a little quick note about this in case you're like, wait a second, you didn't really show us this one. So, okay, let's get to the meat and potatoes of the meal. We've had our aperitif. We've had our entree, our starter. Now let's get into the main course here. We're gonna talk about adding and subtracting fractions. So the reason we've been learning all of these skills of how to convert between improper and proper, or mixed and improper, is really coming down to the adding and subtracting fractions. So here's the big rule that you need to know. This is for adding and subtracting only. Don't worry about multiply, don't worry divide. They're easy, they're coming in a minute, or about 10 minutes or so. Right now, when we're adding or subtracting, you can only add if the bottom numbers are the same. So the bottom numbers of the fractions you're adding have to be thirds or sixths or tenths or whatever they are, but they have to be the same. And that's it stinks because it's often a lot of hard work, but this is how fractions work. And again, I'm going to show you the easier way once you understand how to do them on your own. So essentially what we're going to do is we're going to try to take the rule where we can multiply the top and the bottom by any number or divide it, or we're going to unsimplify so that the bottom number, the denominator, is the same in both fractions. And I'm going to show you guys. So we can multiply both the top and the bottom of the fraction by the same number. So if we have the example 1/4 plus 1/2, we can probably do this in our heads because we've seen it enough. We're going to look at this fraction and we're going to say, hey, wait, the bottom numbers aren't the same. And in order to add them, the bottom numbers have to be the same. It has to be quarters and quarters, or halves and halves, or thirds and thirds. How can I make this so that these bottom numbers are the same? Well, I know if I multiplied 2 times 2, it would make it 4. So if I multiplied this, 2 times 2 would make it 4. But if I'm going to do it to the bottom, I have to multiply it by the top. That was one of the first rules we talked about. So we took our 1/2 and we multiply both the top and the bottom by 2. Gives us 2/4, which makes sense, you know. We went through the half an apple is like saying 2/4 of the apple. Makes sense. So now we're going to rewrite this, and it's 1/4 plus, instead of half, we're going to write 2/4. It's an equivalent fraction again. 1/4 plus 2/4. The bottom numbers are the same, which is awesome. So we just it means that we can add them now, or subtract them, but add them. And so quarters and quarters gives us a quarters. And then you can just go and add the top. 1 plus 2 is 3. So now that the bottom is the same, you can add the top numbers. And the bottom number, the denominator, stays the same. It doesn't change. Okay, I'm going to go to the next one here. 2/3 plus 1/6. So the first thing I'm going to ask when I'm adding these fractions is, are the bottom numbers the same? No, of course not. 3 is not 6. But if I multiplied 3 times 2, it would be 6. So let's do that. And if I can multiply the bottom by 2, then I have to multiply the top by 2. All right, so 2 times 2 is going to be 4. And 3 times 2 is 6. That makes sense. If we have 2/3, see if I can make my pizza right. 1, 2, 3, 4. Same thing, it's just more pieces, that's all. So if you multiply 2 times 2 gives you 4, and 3 times 2 gives you 6. And this one I don't have to change because it's already 1/6. Now my bottom numbers are the same, which is great. So I'm going to add 4 plus 1, which gives me 5. And the bottom number stays the same, 5/6. I'm hoping this is all making sense. All right, I have a feeling I'm going to switch to the next page, and it's going to be a bunch of questions. Oh, we have one more short example. Yeah, because in these ones, we only have to change one of them. In this example, which is often happens, is we got 3 and 4. Well, I can't multiply 3 times, 2 gives me 6. So I have to change both of them, but that's fine. And this is when, in grade 7 probably, or 6, you guys talked about lowest common multiple. And again, we can go over this a little bit more detail, but I'll do that afterwards if anyone wants more help. Essentially what you do is you take this bottom number and you just list the multiples. So 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and 15, and so on. I'm going to do the same thing for 4. I'm going to list the multiples of 4. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 16. You're going to list a few of them, and then you're going to start here and look for a common one. It's got to be the same in both. I can't choose 9 because 9 isn't in this list. I can't choose 4 because 4 isn't in this list. 12 is in both. So the lowest common multiple is going to be 12. And that's probably what I want to make my fraction, is I want to make them 12ths. How do I make this 12ths? Well, I know that if I multiplied this by 4, oops, I didn't really write that 4 very well. It would give me 12ths. And so that's what I'm going to do. So 2 times 3, or 2/3, 2 times 4 is 8, and the bottom 3 times 4 is 12. So I know 2/3 is the same as 8/12. And now we go to the 3/4. Well, I know that 4 times 3 would give me 12. So I have to multiply the top and the bottom by 3. So this is what I've done here. So 3 times 3 is 9 on the top, and on the bottom, 4 times 3 is 12 on the bottom. Sorry, 3 times 3 is 9 on the top, and 4 times 3 is 12 on the bottom. Now that I have the same bottom numbers, the 12ths and the 12ths, now we can add this. So in your head or in your calculator, you go to 8 plus 9, which gives you 17. And the 12ths stays the same. This is a perfect answer, or you can simplify it, put it back into mixed if you want. Often you'll see instructions in the example saying, please leave it in mixed, or please leave it in simplified, or something like that, which is what we talked about in the first couple pages. I'm going to be pretty relaxed about that. I just want you guys to understand these concepts. All right, I'm hoping that some of you guys have started on these ones, but if not, let's go through them together. So the first thing, I'm going to look for the lowest common multiple. So I could list 4 times 1, 4 times 2, 4 times 3, 4 times 4 is 16, and so on. And for 8, 8 times 1, 8 times 2, 8 times 3. And I'm going to look for the smallest one. I could use 24. Sorry, this could be 24. But it's not the smallest one, and so you're just making your life more complicated. It works, but it's just way more complicated if you choose a bigger number. Choose the smallest number, and 8 and 8. So I want to convert both of the bottoms to 8. Well, in order to convert this to 8, I need to multiply by 2. If I'm going to do it to the bottom, I need to do it also to the top. So let's rewrite this. 1 times 2 is 2 on the top, and on the bottom, 4 times 2 is 8 on the bottom. And we're going to add 3/8. None of this changes. The adding stays the same, and 3/8 stays the same. Now that my bottoms are the same, I can add the tops and keep the bottom the same. So add the tops. 2 plus 3 is 5. And my 8ths stays the same. And that's going to be my answer here. Cool, let's do the next one. 3/5 plus 3/4. So I'm going to list a bunch of the multiples of 5. 5, 10, 15, 20, 25, and it keeps going on. Pretty sure I'll get it by there. And 4, 8, 12, 16, 20, 24, and goes on from there. I think I see my common one. Nothing, 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 but I know that 20 would work for both of those. That's probably my smallest, so my LCM, the lowest common multiple. These are all multiples, and the common because of the sames, and it's the lowest. So that's why it's called the LCM. So I want to convert these into 20ths. In order to convert this to 20, I'm going to multiply by 4, because 5 times 4 is 20, so I have to multiply the top also by 4. And the same way, well, I'll just finish this one. So 3 times 4 is 12, and 5 times 4 is 20. Okay, we have to also convert this one. In order to make this 20 on the bottom, I'd have to multiply it by 5. So I'm going to do the same thing to the top. My plus stays the same, so I'm not going to change it. 3 times 5 is 15. And on the bottom, 4 times 5 is 20. Now that my bottoms are the same, I'm going to add my tops. So 12 plus 15 is 27. And the bottom is 20. And let's just leave it at that for now. Cool. Let's do this one. I'm going to just keep going, you guys, only because I'm starting to run out of time already. One of the easiest ways, well, The best way to do it is the way that we're doing it. One of the easiest ways is you can multiply this by the other fraction. So I can make, and then multiply this by 8, the other number. You could do it that way, and it will come out. What I'm going to do is I'm going to do it the proper way, though. So I'm going to list. It's going to be 8, 16, 24, 32, 40. Oh, I know already. 10, 20, 30, 40. So I want to make them both 40s. At the bottom number 40. So I'd multiply that by 5. I'm going to multiply the bottom, and I have to multiply top by 5. And for this one, I'm going to multiply both top and bottom by 4. So this will be 40 and then something. So let's figure this out. 6 times 5 is going to be 30. And then the bottom, it's going to be 40. And here, 1 times 4 is 4 on the top. And 10 times 4 is 40 on the bottom. Cool, the bottoms are the same, so I can now add these. So 30 plus 4 is 34 over 40. And I hope you guys can see and nothing's getting in your way here. There you go. And the last one, I figured I would throw in a bit of a trick here. It's like, what do you do with a mixed one? Oh, you know what you do is you convert it to an improper fraction, and then you're off to the races. So remember the little arrow here? We're going to multiply and then add. So 8 times 1 is 8, plus 3 is 8, 9, 10, 11. So this could be 11 over 8, which is essentially the same thing. It is the same thing, plus 2/6. And I'm going to list my multiples of 8, 16, 24. This could be 6, 12, 18, 24. Oh, 24 is the number. So I'm going to multiply. I'm sorry, I'm making this really small. 3 times 8 would give me 24. And this one, 4 times 6 is 24. So I'm going to multiply the top and the bottom by 4. Again, I can go over this one in a bit more detail later on, or if you want me to go back. So 11 times 3 is 33. I'm not writing very big, am I? And 8 times 3 is 24. Plus 2 times 4 is 8 over 6 times 4 is 24. This is awesome because I want my bottom numbers on the fraction to be the same. If they are, then I can add them. So 33 plus 8, which is going to give me 41 over 24. I'm pretty sure that's the answer. Yeah. Okay. Take a big moment to breathe. We're going to blast through the rest of this. Subtracting fractions is the exact same thing. You have to have the same bottom number. So all of the rules apply. When you do have the same bottom number in the fraction, then you can just subtract them. It's easy. So let's figure that out. Multiples of 2 are 2 and 4 and 6 and 8. And I'm pretty sure the multiples of 8 are 8, and that's the lowest common denominator. So let's make both bottom numbers 8. In order to make this 8, I need to multiply by 4, and so I'm going to do it both the top and the bottom. So 5/8. 1 times 4 is going to, so this is going to be a minus because it's obviously I'm not changing the sign. 1 times 4 is 4, and 2 times 4 is 8. Now that the bottom numbers are the same, I can actually do my subtraction. 5 minus 4 is 1, and the bottom number stays the same. And there's my answer. Same deal. Same as almost all identical to the adding. It's just you subtract at the end. Let's do this one. I'm just going to be able to, can you scroll up? Absolutely. How do you know if you have to make both bottoms the same? So when you're doing adding and subtracting, you can only add or subtract fractions that have the same bottom number, same denominator. So you have to do this step. And that's what makes them such a pain in the butt. Because I can't say, oh, 5 minus 1 is 4 and 10 minus 9 is 1. That's just, no, that's garbage math. That's just pretend math, maybe in some other universe. Absolutely. Let me just scroll out a little bit here. I see. I'm sure that you're probably ahead of schedule here. What I'm going to do is I'm going to list 9, 18, 27, 36, 54, and it goes all the way up to 90. Pretty sure that's what it is, and 10, 20, 30, 40, 50, 60, 70, 90. So I'm just going to make them 90s. In order to do that, I'm going to multiply by 9. Sorry, guys, I'm just going to make this a bit smaller because someone's just asking to see the bottom questions so they can practice these. Okay, this is times 9. So 10 times 9 would make 90, so I have to multiply both top and bottom by 9. 9 times 10 would be 90, so I have to multiply top and bottom by 10. So 5 times 9 is 45, that one, over 90. And then 10 times 1 is 10, 90. So we have 35 over 90. It's not simplified, but I'm fine with that for now. And it's your guys' turn, obviously. Again, when I'm looking at the bottom numbers, sorry, I just noticed someone wrote me a quick little note here. Yeah, let me get back to that in just a moment. Okay, I'm going to look at that in just a moment. Can we shelve that just for a few minutes? I really want to sort of blast through towards the end, and I still got a little bit more. I don't want to keep anyone, but I will definitely come back to that. Okay, last question. Is it this one that you want me to? Maybe what we can do, again, can we just shelve that? I just want to go through a few of these examples, and then we will definitely come back because we have 1, 2, but those are easy. And then we've got the test questions. And I also want to talk about the fraction calculator. The one before. Definitely, can we do that again? I'm just going to suggest if there are people asking for questions to go over them again, can we just hold off for maybe 10 minutes, I'm guessing, and then I'm happy to go through 100 different more examples with you. So with the bottom numbers are not the same. We need to have the bottom numbers the same in fractions in order to add or subtract them. So I'm going to list off multiples of 6 are 6 and 12 and 18. 6 times 1, 6 times 2, 6 times 3, and the same thing, 2 times 2, 2 times 3, 2 times 4. 6 is going to be my lowest one, so that's what we want to make them. This is already 6, so 5 sixths stays the same. What would we have to multiply the 2 to get 6? Well, 2 times 3 would. So if we multiply the bottom, we have to multiply the top as well. And so 1 times 3 is going to be 3 on the top. 2 times 3 is 6 on the bottom. Now we definitely can add or subtract these because the bottom numbers are the same, sixths and sixths. So 5 sixths minus 3 sixths gives me 2 sixths. 5 minus 3 is 2, and the bottom number stays the same. All right, let's do this one here. Erase some of this. All right. Yeah. Let's list the multiples of 6. So 6 times 1, 6 times 2, 6 times 3, and same with 4. And yes, absolutely, we can definitely, if people are really falling behind, we can certainly sit down and talk about that. 4 times 1, 4 times 2, 4 times 3. Oh, I see one that's in common already. It says 12ths. So how do we make this 6 into a 12? Well, we would have to multiply it by a 2. If we're going to do that, we have to multiply the top also by 2. So 5 times 2 is 10. 6 times 2 is 12. We still have to switch this one. So what would we have to multiply 4 to give us 12? 4 times 3, perhaps. And if I get multiplied by on the bottom, I also have to multiply it by the top. So 1 times 3 is 3 on the top, and 4 times 3 is 12 on the bottom. Cool. Now I have the bottom number, the denominators are the same on the bottom. So now I can just subtract on the top. 10 twelfths minus 3 twelfths gives me 7 twelfths. Cool. Let's go to the next one, 9 and 2. So I'm going to say 9 and 18. That's probably as far as I have to go. 2, 4, 6, 8, 10, 12, 14, 16, 18. Hey, there's my 18 is my common or lowest common denominator or multiple. So I want to make both the bottoms 18. That's the only one they have in common. So that's what we're trying to do here. So I'd have to multiply this by times this by 2. Let me just go in a little bit. And if I can multiply by 2 on the bottom, I have to do it to the top. And same with this. What do I have to times 2 times what gives me 18? 2 times 9. So I'm going to multiply the top and the bottom by 9. So let's do it. 8 times 2 is 16. And 9 times 2 is 18. And then 1 times 9 is 9. And 2 times 9 is 18. Now that my bottom numbers are the same, the denominator is the same, I can actually subtract them. So 16 minus 9 gives you 7, is it? Yeesh. My brain's having a little bit of a meltdown here. 7/18. And again, the last one, I'm going to convert this to an improper. So 20 times 1 is 20, plus 1 is 21 over 20, minus 2/5. What's the common denominator? What would be the lowest common denominator? It's going to be 20. I can tell right away. 5, 10, 15, 20, and this is 20. So let's multiply both the top and the bottom by 4. This would give us 20 on the bottom. Who cares what goes on top right now? And this one's already 20ths, so that's perfect. So 21 20th minus 2 times 4 is 8, and 5 times 4 is 20. 21 minus 8, I want to say it's 13. I hope that's right. 20ths. Awesome. Okay, guys, this is breakneck speed here. I'm just going to keep going because I don't want to delay us any longer. This is taking a little longer. I know it's a lot of pages. Adding and subtracting mixed fractions. So you just have to convert it to improper fractions and solve. So again, I'm going to draw my little arrow here. 6 times 1 plus 1. So 6 times 1 is 6, plus 1 is 7. And the bottom stays the same. Same with this one. This is going to be a times, and this is going to be a plus. So 2 times 3 is 6, plus 2 is 7, 8. So it's 8, and the bottom number stays the same. Now we've got this problem, which we've been doing for the last 15 minutes. Hopefully, I'm going to finish up this meeting really quickly. So just hang on for a sec. 6 is going to be the common denominator. So 3 times 2 would give me a 6 in the bottom. If I'm going to multiply by 2 on the bottom, I have to multiply by 2 on the top. So 7 6, this stays the same, plus 8 times 2 is 16 over 3 times 2 is 6. Now that my bottom numbers are the same, I can add the tops. 7 plus 16 is 23, and the bottom numbers stay the same. And I've made this into a mixed fraction. Here's another example, and it's a subtraction, but it works the exact same way. 2 times 4 is 8, plus 1 is 9 halves, minus, and let's do the arrow again, 3 times 1 is 3, plus 2 is 5 thirds. I'm going to decide 2, 4, 6, and 3, 6, 9. 6 is definitely, even if I write that properly, 6 is the number, so if I'm going to make this bottom a sixths, I have to multiply by 3, so I'm going to do that to the top and bottom. So 9 times 3 is 27 sixths. And I want to change this thirds to sixths. So I'm going to multiply by 2 to the top to the top and the bottom as well. So it's going to be 2 times 10 or 10 sixths. Now that my bottom numbers are the same, I'm going to keep them as sixths. We're just going to subtract the top. So 27 minus 10 is 17, or 17 sixths, or 2 fifths, and 5 sixths. We've done a few of these. I'm going to come back because I really want to just talk about multiplying and dividing fractions. And these are way easier. You're going to love them. Compared to these things, they're way easier. I will come back at the end and look at these two examples, if that's all right. Let's look at multiplying fractions. We've actually been doing it this whole time. We didn't even know. These are super easy. Step 1, you multiply the top numbers. Step 2, you multiply the bottom numbers. That's it. So in my example, I've got 1/2 times 4/3. I'm going to multiply the top numbers. 1 times 4 is 4. On the bottom numbers, I'm going to multiply those. 2 times 3 is 6. There's my answer. Let's look at this example here. Looks like a terrible one, but you know what? It's pretty easy. When you're multiplying fractions, you multiply the tops to give you 9 times 3, which is 27, and you multiply the bottoms. 16 times 2 is 32. Now, this might not be simplified, but that's all right. Well, actually, that is simplified. Let's do a couple of these here. So multiplying, you're going to multiply the top. 1 times 3 is equal to 3. And on the bottom, 2 times 4 is 8. Sorry, skipping ahead here. 2 times 4 gives you 8. Easy. These are so awesome, actually. Let's do number B. When you're multiplying them, you multiply the tops. So 5 times 7 is 35. And on the bottom, you multiply the bottom numbers, the denominator. 6 times 4 is 24. Done. All right, number C. This is a bit of a trick question, but it's going to work. When you're multiplying fractions, you multiply the top by the top. So 9 times 1 is 9. And on the bottom, 3 times 3 is 9. Oh, 9 divided by 9, that's actually 1. It's not a trick question. And the last one is a bit of a trick question. You have to convert this to an improper. 2 times 1 is 2, plus 1 is 3, times 5/9. Now it's super easy again. We've got a multiplication, so multiply the top by the top, so 3 times 5, which is 15. And on the bottom, 2 times 9 is 18. I hope these make sense. I'm going through them very quickly, but they don't really take that much time and effort. And finally, last page here. Dividing fractions are almost as easy, and they're super satisfying. They totally are satisfying. You need to do 2 different things. First, what we're going to do is we're going to flip the divide sign and make it the opposite. We're going to make it a times instead of a divide. If we flip the sign, the divide sign, and make it a times, then what we also have to do is flip the second fraction top to bottom, bottom to top. And maybe it'll be way easier if I explain this, but you can certainly look at these rules if you have to do a dividing question. So if we have 1/2 divided by 4/3, what we're going to do is we're going to flip the sign to make it a times. And we're also going to flip the second, the next, like the one on the right, we're going to flip this fraction top to bottom, bottom to top. So 3 goes on the top and 4 goes on the bottom now. Now we have 1/2 times 3/4, and it's the same as the multiplications we just finished doing. Because it's multiplication, we're just going to multiply the tops. 1 times 3 is 3, 2 times 4 is 8. I'll do one more example, and hopefully it'll all make sense. 9/6 divided by 1/4 So we've got a dividing a fraction. So what we're going to do is we're going to flip the two things. We're going to flip this sign. So it's going to be a times instead of a divide. And we're going to flip this fraction. So the number on the top is the bottom, bottom is on the top. So it's 4 times 1. Now it's easy. It's a multiplication, so we multiply the tops. 9 times 4 is 36. And 6 times 1 is 6. And 36 divided by 6 is going to be 6, essentially. And this is just the simplifying, which we won't worry about right now. Okay, I'm going to do a couple more here. I just want to do maybe one more here, and then what I'll do is I want to talk about the calculators really quickly. And as soon as the calculator is done, you're welcome to do your test on your own. Again, you guys know where to submit it. It's always in the LlamaMath in the Canvas course. I'm happy to grade it. If you have questions, I'm happy to stay afterwards and help you guys out, even help you when you get to the quiz. And I'm also going to show you how you can use these calculators to double check your answers. So let me just do these really quickly. 4/5 divided by 2/3. So if we're dividing a fraction, there's 2 steps. We're going to flip the sign. So we're going to change the divide into a times, but it also means we have to flip these fractions top to bottom, bottom to top. And now we have a really easy multiplication. So when we have multiplying fractions, we multiply the tops. Oops. 4 times 3, which is 12. And on the bottom, 5 times 2 is 10. And this could be like 6 over 5 or 1 1/5, all of which are fine. Let's do number B. 1/6 divided by 5/6. Well, the 1/6 stays the same, the first fraction. We're going to flip this sign to make it a times. We're going to flip this fraction to make it top to bottom, bottom to top. Now we've got a multiplication, so we multiply the tops. 1 times 6, which is going to be 6. And multiply the bottoms. 6 times 5 is 30. And then I can simplify, divide both top and bottom by 6, and it's going to be 1/5. But 6 over 30 for now is just perfect. Oh, I might as well. We're so close. I'm just going to finish these. Again, we're dividing a fraction, so 4/7. Going to flip the divide sign and make it into a times. We have to flip this fraction. You don't have to simplify it every time. I'm not super fussy about this right now, as long as you know how to simplify it. What you will see is as you get further and further in math, your teachers will definitely say, the question will say solve and simplify. And if you don't simplify, you lose half a mark or you lose a mark. But this is why these calculators are going to be so helpful, because it simplifies. That's the biggest deal for those things is just to simplify the fractions. We have a multiplication, so let's multiply the tops. 4 times 5 is going to be 20. And 3 times on the bottoms, we're going to multiply 7 times 3, which is 21. And there we go. And it is simplified. And the last one, it's probably the hardest one out of them all. Well, actually, no, we've already done the hardest ones of them all. Let's convert these to improper fractions or top-heavy fractions. So we do that by saying 2 times 1, which is 2, plus 1, which is 3. And this one, 2 times 4, which is 8, plus 1, which is 9. Again, I'm going through pretty quickly. You don't definitely have to, you don't have to figure this out this quickly. I'm quite used to these. But this is all stuff that we've learned throughout the lesson today. All right, we have a divide. So let's multiply the reciprocal or the flip of 4/9. Perfect. Now we have a really easy one. It's a fraction times a fraction, so we multiply the tops. 3 times 4 is 12. We multiply the bottoms. 2 times 9, which is 18. And that is not simplified because I could divide that by 6. I think that's what it is. It's 2/3. Same deal. All right. I want to go to the test really quickly before I lose anyone else. And thank you again for your patience. I did not write this on the test, but I really want to make sure that this is clear. Make sure to show your work. I really want to see what you're doing. When you go 20 divided by 20 30ths, I don't want you just to give me 2/3. I want you to tell me, oh, divide the top and the bottom by 10 and it gives you 2/3. Perfect. That's what I want. Some of these are really easy. Or when you say, you know, even on this one, you're going to put, even if you put a times and a plus, or if you put the arrow in there and you put this there and you've sorted out, that's the kind of thing that I want. I don't want you to see every single minute calculation, but I want to see that you just didn't plug it into the calculator and say, oh, that was easy, because I would like you to do that as a double check. Absolutely. But what I do want is if you can show your work. You know, so with this one, don't just give me an answer of somehow, you know, it's going to be 15 tenths or 16 tenths or whatever it is. What I would love is to see your work. So I want you to change these both to tenths. So 4/5 will be 8 tenths plus 7 tenths, which is going to be 15 tenths, which is going to be 1.5, or it's going to be 3/2. You can see some of these, it says, and simplify. So again, if you don't, I might take a half mark off, or I might have something for you. Depends on how hard it is. And hopefully, if you have a calculator on your computer, or on your device, or on your calculator, then it should be able to do that for you. So I want to show you really quickly before I leave here. This is one of the ones that you can download both for iOS and for Android. If there's any others out there, I don't know. This is a good one. It's free. This is why I've chosen it. So what you're going to do, and I couldn't figure out how to do an emulator to show you what these things look like. But I'm going to essentially show you how you do it. If you wanted to do this question, is 2 1/5 plus 5 3/7, what you do is you click on 2 and then 1/5, and it's got it right in there. And then you're going to go plus 5 3/7. This is the dividing line of the fraction, and this is the whole number. This is going to be the numerator, and it's going to be denominator, bottom number. I don't know what I spelled there, but that's all right. And so this is a great tool, honestly, for doing these kind of questions. What it'll also do, and I'd love to show you on this, but you just won't be able to see it. It will simplify, and I believe that there's a spot here. Let me see if I can show it to you. Yeah, there's ads in this too, so apologies for that. It's just a free tool, so this is as good as I can get. There's a little tool up here, and I think there's a bunch of lines, and it'll actually show you all the steps involved in doing it. So it'll show you how to change these in imperfect, and then what to multiply each of them by to get the common bottom number, common denominator. It'll actually do that. I'm going to see if I can do that here. I'm going to do 1.5 plus 2 3/5. So it gives me 4 1/10, which I trust is good. Let me just see if I can unshare this. I want to really see if we can solve this here for a moment, you guys. Okay. This is really terrible. There's a button right over here. I'm going to hit it. And what it does is it shows you all the different steps on how to get your answer, which is awesome as well, because it'll show you, it'll walk you through how these are done. Also, what I want you to do, what I want to show you, let me just go back to share my screen again. If you have a calculator button, the calculator button, let me just see if I can come up with a new one here. No, that's not what I want. I just want a new. Okay, that's going to work. On the calculator, there might be a button. Now, why I like a calculator is because in future math, your teachers might say, no, no, no phones, no phones, because there are apps that will actually solve all these problems for you. I'm going to show you this at the end of the course so that you know that you can double check all your answers. You can just scan a formula and it'll do all the work for you and show you all the different steps. It just doesn't really encourage you to learn the basics. So a lot of teachers will say no phones, but they will allow you to have a calculator. And especially if you have, at the start of the year, if you advocate for yourself and you say, you know what, I really do much better when I have calculators to double check. Most teachers, math teachers, just want you to learn the math. They don't want to stick you and say, oh, you didn't learn this and you're going to have to learn it, unless they're crotchety and old. So a calculator is great. And they'll say, yeah, you can use a calculator. And then you have the fraction button. And what you can do is when you do this, I would hit 3 and then this button and then 4, and that would give me 3/4. Oh, I've just dropped my pencils. Or if I have 3 and 4/5, I would do 3 and then this button and then 4 A, B over C, 4/5, and it'll actually type it in there and it will reduce this. This is really helpful. This button, especially, like I said, when you reduce fractions, what if you have 1065 over 235? You have to reduce this fraction. It is such a pain in the butt. It's like, okay, I can divide both by 5, but is there bigger numbers? Like, it just is a lot of work for not that much payoff. And this is where this button would help, is if you went 1065 and you hit this button and then you did the 235, it'll reduce it. I don't know if my calculator will actually go this high. Maybe I'm going to make this, not the 10, but 865 over 235. 865 over 235. And my calculator is so old. And it gives me 3 and 32 over 47. That's going to be just a messy math equation when you have to do it by hand. And you could do it by hand, and hopefully your teacher won't torture you by making you do it by hand. And this is what these things are fantastic for. So again, that's my plug for calculators. If you want more help with this, stay on, ask me some questions, and we'll figure out your calculator. We can like share back and forth so that you know how to use these screens. So at this point, thank you for hanging in there. You guys all should have access to your Chapter 3 test that involves fractions. Please, by all means, use a calculator. Use a fraction app, calculator app on your phone if you want. But I want you to show your work. If you don't show your work, it's really kind of pointless that you sat through this 1 hour. It's good to know how to do these, but you can use your calculator to help. When you're simplifying 45 divided by 1,000, it's like, well, I think I can divide by 5, but what is 45 divided by 5? You can do that in your calculator. 45 divided by 5 gives you 9. Cool. And 1,000 divided by 5 gives you 200. Cool. So again, show your work and finish the test. If you want to stay here to write the test, that's awesome. If you feel like you can do it on your own, then that's also awesome and you're free to go. And what I'm going to do is, I know that I've skipped a couple of questions, maybe 2 pages ago, so I'm going to go back and do those for anyone who wants. If there's anything else that you want me to cover, I'm happy to stay here for at least a while and do that with you. How do you simplify your mixed fraction? Awesome, cool. So I'm going to get to that in a minute. Okay, yeah, thank you again for everyone showing up. Next week, it's going to be graphing, linear functions. It's pretty exciting. Again, it's going to be a full lesson, and I'm trying to keep it down to an hour. I went over today by a big time, And so I'll make sure that I try to really adjust that next time. I'm just going to take about 30 seconds to write a couple of messages, and then I'm going to go back to the page. I think it's, no, it wasn't that one. That one. Okay, I'll just be a second.
On the test, I do believe you can. I think it's not that you can say your schedule or something, just save that.
And thank you again, everyone who hung in there so patiently today. Okay. So again, I've gone to, oops, that's the wrong way. Chapter 3, page 6. We're just going to add and subtract these. Yes, absolutely, you are allowed to leave, and good luck in writing the test. I'm sure that you won't have too many problems with it, especially since you can check the answers. And again, show your work if you can. That's what I want. Okay, last couple of these, and then I'm happy to do another 20 or 30 of these, as many as you want. Okay, so we're adding these fractions, but they're mixed right now, and I want them to be imperfect. So I want them to be top heavy, and that's where we're going to draw the arrow to figure them out. And you remember with the arrow, it's going to be a times and a plus. So when we do this, it's going to be 3 times 1, which is 3, plus 2 more, so 4, 5 on the top. And we're going to keep the bottom the same, 5/3. You can think of this as also 1 is 3/3 plus 2/3, which is 5/3. But this way is easier. To me, it's easier. Okay, we're going to do the same thing on this one. We're going to take the bottom number, the 2, times the whole number, times 2. So 2 times 2 is 4, plus 1 is 5. Oops, I didn't mean to make them equals. Whoa, that was weird. 2 times 2 is 4, plus 1 is 5. I will get to those test questions in about 3 minutes here. And the bottom number stays the same here. We're still dealing with halves. So now we have to convert these to the same denominator. So I'm going to say, okay, multiples of 3 are 3 and 6 and 9 and 12. 3 times 1, 3 times 2, 3 times 3, 3 times 4. Multiples of 2 are 2 and 4 and 6. And I'm just going to stop there because 6 is my magic number. That's the smallest one. So what do I need to multiply this to get me 6? I'm going to multiply it by 2. So the top and the bottom, I'm going to multiply by 2. I just worry that as long as this gets a 6, I don't care what I'm multiplying the top by for now. What I want is the bottom numbers to be the same. Here we've got halves. What do I have to do to make them sixths? Well, 2 times 3 would give me a 6. So I'm going to multiply the top and the bottom by 3. Cool. So now 5 times 2 on the top is 10. 3 times 2 is 6 on the bottom. Let me move this over. There. 5 times 3 on the top is 15. 2 times 3 is 6 on the bottom. Now that I have the same bottom denominator, bottom number, I can add the tops now. 10 6 plus 15 6, or 10 plus 15 is 25. And sixths stay the same. Gosh, I should practice saying that 10 times fast. And that's going to be my answer. All right, let's go to this one here. I'm going to change these to imperfect. I just think of someone like the 1800s who's not wearing a proper hat. I don't know why. Anyways, here we go. I'm getting distracted already. We're going to multiply and then we're going to add. So 2 times 3 is 6, plus 1 is 7. Halves stays the same. 3 times 1 is 3, plus 1 is 4. And thirds stay the same. Convert a fraction into a mixed fraction. Yeah, okay, let's do that. That would be on page, sorry, I'm just taking the time for a second. It's on page 2 or something like that. No, maybe it's on page 3. How to convert an improper fraction to a mixed fraction. There you go. And that's on page 3. Okay, sorry guys, I'm just being totally distractible. Okay. We've got this fraction subtracting another fraction, but the bottoms aren't the same. I'm pretty sure that they're going to be sixths again, so I really want to punish myself. I'm going to multiply the top and the bottom because I have to, 2 times 3 would give me 6. So I'm going to do the same thing to the top. Here, if I multiply 3 times 2, give me 6. So I'm going to do the same thing to the top. So let's do it. 7 times 3 is 21 over 6. And it's going to subtract 4 times 2 is 8. And on the bottom, it's going to be 6. Now that I have the same bottom numbers, I can just add or subtract the tops. So 21 minus 8 is 13. Wow, it feels like I just did this question. Okay. You know what? I'm going to just go back into the chat for a minute. Okay. How do you know if you have to make both the bottoms the same? Okay, so that's a really good question. I just want to write that here. The bottoms have to be the same, oops, when adding fractions or subtracting fractions. Those are the two cases. The multiply and the divide, we don't care about the bottoms. When you are adding fractions or when you're subtracting fractions, the bottoms all have to be the same. It's like this. Let's say, oh, I'm just trying to think of something that's not a pizza or an apple. Okay, I'm just going to use apples or because they're easy to draw. If I have half an apple plus, sorry, half an apple plus 1/6 of an apple, if I go give those to my 2 kids, one would complain so much because they got the small piece of the apple and not the big piece. So when we're adding them, we're figuring out how much we have. We can't say, oh, well, we got 2 out of how many pieces. That doesn't really make sense because this one's way bigger. You have to compare apples to, or you have to compare the same things. You know, so when you're adding or subtracting or comparing, they have to be the same size. They have to be equal portions. So when you're adding or subtracting, they all have to have the bottom same number. I hope that answers the question. I'm going to go, do you still want me to cover question number 3 and 4 on the test? Just to look at those really quickly.
Yeah, just as long as things aren't getting missed.
All right, so let's do it. So we're converting to a mixed fraction. Let's look at the mixed fraction just for a moment here. Oh, that's the adding. Sorry, I just have to find where we're going.
I don't understand the biology. Doesn't really come to me. Yeah, left side, logical things.
Okay, so I think this is the page we want. Sorry, I'm really just trying to struggle with it. So convert to a mixed fraction. So these improper to mixed. So this is the ones where we were saying it's like a division with a remainder question. And we're asking, okay, in this example, how many groups of 5 can we get out of 17 and what's the remainder? So let's do these ones. So here we're going to say, how many groups of 10 can we take out of 46 without going over? Well, I know that if I took out 4 groups, I'd have 40 with 6 left over. Okay, so let's use it. $40 would be 4 groups, and I would still have 6 left over, right? And 40/10 really is 4. So that's going to be 4 6/10. It's not quite simplified. I know that the 6/10 can be a bit more simple. Why don't I divide that by, I know I can divide it by 2. Can I divide it by 2 or 3? So let's just do 2. Divide both the top and the bottom by 2. So 4, 6 divided by 2 is 3, and 10 divided by 2 is 5. Does that make sense? Let's do this one here. How many groups of 7 can I get out of 30? Well, what is 3 groups? 3 groups of 7 is 23 times 7 is 21. I think I can get one more. 4 times 7, which is one of the, it's one I've never really memorized properly. It's 28. Hey, 28 is really close to 30. So what I'm going to do is I'm going to break this 30 sevenths into 28 sevenths. Oops, I didn't quite go right. And I'm going to still have 2 more as a remainder, right? And 28 divided by 7, you can even do that inside your calculator. 28 divided by 7, 28 divided by 7 gives you 4. Or 4 2/7. And I'm pretty sure if I can do a bunch more of the examples if you want. Let's see if mine will actually do it. 28 sevenths. Sorry, I want to do 30 sevenths. I'm just going to double check my answer. And I don't know if you can see. It's probably too hard to see because I'm on a little screen. It does give me 4 2/7. Maybe what I'm going to do is I'm going to look at question number 4. I'm going to give you the first little step, and I'll nudge you in the direction. And then if you still have problems, then I can do them some more. So we can look at these. We can look at this type of question in the next few minutes. If you're still having problems with that type, then no problem. I know someone was saying they wanted help with number 4 as well. And we get to leave them as improper. That's great. So again, we've got a fraction. We're adding a fraction. So when we're adding or subtracting fractions, we need to have the bottom numbers the same. And they're not, of course. So what we need to do is need to find a common number for those. We could we could say 5 times 1, 5 times 2, 5 times 3, 5 times 4, and just list them out and say 10 times 1, 10 times 2. So that's maybe what I'm going to start with. So it'll be 5 times 1, 5 times 2, 5 times 3, 5 times 4. Yeah, absolutely. If you're done the test, you're good to go. You're extra good to go. 10 is going to be the number. Thank you so much. This is awesome. And so what I'm going to do is I'm going to multiply the bottom by a number to make it so it will be 10. So if I say 5 times 2 would give me 10. If I'm going to multiply by 2 on the bottom, I have to multiply by 2 on the top. So again, 4 times 2 on the top is going to be 8, and 5 times 2 on the bottom is going to give me 10. And the 7/10 didn't change. Now that the bottom numbers are the same here, then you can just add the tops. I like to think of it as this. It's like 8/10 plus 7/10 is 15/10. The same as 8 apples plus 7 apples is 15 apples, or 8 oranges plus 7 oranges. The tenths is just like 8/10 plus 7/10 is 15/10. The simplify is the part that we're going to worry about now. Is there anything that I can divide, a whole number that I can divide both the top and the bottom by? Can't be 2, because this won't go. Can't be 3. This would work, but 3 doesn't work. 4 doesn't work. 5 maybe. So I'm just giving you a hint here. If you're going to divide and multiply the top, then you have to do the both. How do you leave a fraction improper? Oh yeah, okay. That's no problem. An improper fraction, you realize, is, you remember, one where the top number is bigger than the bottom. It's like the top heavy one. So this is an improper fraction. And really, I just put that there so that you wouldn't say, oh, this is probably going to be 1.5, which is a mixed. This is the same question. This is the same answer. Sorry, it's just, I didn't want to have to make you guys switch them to mixed. There we go. I am very happy to answer anyone else's questions. I think I've probably covered a lot of them. So if anyone else has a question, please just fire away. I haven't even looked at this page yet. Oh, these aren't so bad.
But you know him better than I do.